Good morning, good afternoon, good evening for a few of you. And thank you for joining us for today's exciting webinar titled Integrative Analysis of the Aachen Geothermal System with an Interdisciplinary Conceptual Model, presented by Dr. Esteban Gómez-Diaz. My name is Dr. Adeline Parent, and I have the privilege of serving as the chair of the EAGE Geothermal Energy Community. And I am very delighted to be your host today for this webinar as we explore this fascinating dynamic of the Aachen geothermal system. The city of Aachen in German is actually also known as Aix-la-Chapelle in French, Aachen in Dutch, or Achea Grani in Latin. And it is famous for its mineral-rich thermal spring, which have been known for their healing properties over the 2000 years. And I lived there for 12 years. So I, for once, am very excited to learn more about the geothermal system of the area and the interdisciplinary approach that Dr. Gómez-Diaz will share with us today. So I'm going to introduce a little bit of our community, and then I will let Esteban Gómez-Diaz present the subject. Then I will have opportunity to read your questions. So feel free to, start writing the question in the chat. We will also unmute so you can ask directly the question to Esteban, and then we will conclude the session. So who are we, this geothermal energy community? We are a community of people that are very passionate of all things about geothermal. And our goal is to share the knowledge, exchange ideas, and to dive into the latest trends, case studies, and exciting new application of the world of geothermal energy. So whether it is shallow or deep systems generating heat or power, or working with conventional or unconventional method, we are here to explore it all. We also love connecting the dots between geothermal energy and other subsurface technology. And we love finding ways to combine resources and skill to unlock even greater potential. And I'm sure Esteban is going to show you a few of those. Now, we have 13 very active members in our community right now, committee actually, and you can meet us all around Europe, and mostly you can meet us in international conference. And for example, few of us were EAGE Annual in Toulouse before the summer, and then few of us will be in EAGE Get in Rotterdam in October. So before we dive in today's session, which I'm sure you are excited about, let me just take a moment to introduce you a little bit of what we are doing specifically. So we are participating in the EAGE Annual, AGET and APG EAGE workshop in geothermal energy that happened in the Middle East. We participate in educational and network events in collaboration, for example, through this webinar series that we're doing right now. By the way, if you have any subject that you would love to present that are related to geothermal, feel free to contact us. And we will be happy to, give you the floor to express yourself and then present any exciting subject on geothermal. We also like to have and spread the word of geothermal through news, career advice, and vacancies. So we have a linking page, and you're free to actually join us. And we can do also meetups during conference and workshops. Now, what we did for the EAGE Annual in Toulouse just before the summer, we created 3 very successful dedicated sessions. One was called Geothermal Energy in France, a game changer for accelerating decarbonization. And it happened actually it was the first day of the conference. It was very successful, a lot of questions, a lot of people coming from the French government coming to that session. We had the advance in geothermal carbonate reservoir characterization, same as above. It was very successful, a lot of interesting discussion. And we had one subject that I personally like, which is the challenges of repurposing an oil and gas well to geothermal well. And again, a lot of interesting subjects. And we are thinking of talking again about that subject in the future webinars. Now, this is us. This is our Geothermal Energy business card. So if you have your phone nearby, you can take it and then take a snapshot of this QR code, which will direct you into our LinkedIn page. You can also find us in LinkedIn by tapping EAGE Geothermal Energy. Now, here is the upcoming conference, which is an important one for us, the geothermal community. This is the EAGE Get, which will happen, as you can see, between the 27th to the 31st of October. And it will be in Rotterdam, the Netherlands, exactly like last year. Now, for what you are going to see related to geothermal energy is 5 subjects. One, you will see a dedicated session, which is in the strategic program. This is inclusive energy transition, empowering women, advancing equity. And then you have 4 dedicated sessions. The first one is from mine to megawatt, geothermal heat storage and sustainable energy. The second one is advancements in drilling. So again, the subject that I like, drilling, technology of geothermal energy from shallow to deep resource extraction, enhancing geothermal energy deployment in district heating and cooling network, and finally, energy from the matrix, geothermal from classic sediment formation. Now, an upcoming event as well from the 12th to the 14th November 2025 is the 3rd EAGE workshop on geothermal energy in Latin America, which will happen in Guanacaste in Costa Rica. And another thing that is interesting is the masterclass Geothermal Energy with 3 main subjects. So you will have geothermal energy system and their role in energy transition by Andrea Mostacchiello. And then you will have geothermal reservoir engineering of energy production from Denis Voskov. And then finally, the new trend in borehole geophysics for geothermal exploration and deployment by Sebastian Soulas. And this will happen between the 17th to the 20th of November. So, an upcoming webinars that will happen on the 30th of September at 3 p.m. Central Europe time is actually geothermal and petroleum system analysis together. The latest news, and it will be a webinars combining the basin and petroleum system analysis community and the geothermal community, and it will be presented by Bjorn. But now it's enough with all of that and me and all my blah blah. Let's dive in and begin with what I'm sure will be captivating and insightful session. So without further ado, please join me in welcoming Dr. Esteban Gómez-Diaz. And Esteban, the floor is yours.
Thank you, Adeline. That was a very interesting introduction about the geothermal. Well, thank you for everyone for attending. Let me share. Full screen. Okay, so I guess you can, see my screen. Everything works. So, again, thank you so much. Today I'm gonna talk about a part of my PhD thesis. This is just one section, in which I'm gonna talk about the great question here in Aachen, how there is a real geothermal potential here, how it works, why there is thermal water here. So when I arrived here, didn't have too much information about that. Yeah, they make some research, but I want to go deeper in this. So yeah, the title is Integrative Analysis of the Aachen Geothermal System in Germany with interdisciplinary conceptual model. So first, I'm gonna brief talk about me, a little introduction, what I've been and what is my experience in geothermal research. I did my bachelor in Afit University in Colombia in geology. Actually, since my bachelor, I involved in geothermal exploration, where I achieved I did my thesis in geothermal exploration, in geochemistry, analysis of the thermal waters there in Colombia. I also had the opportunity to did my master in Iceland in Reykjavik University in sustainable energy. There, I focus more in reservoir engineering, where my master thesis was focused, especially in a lake, in an Esjapetlir lake in Iceland, where I was looking the how the like a fracture model and the thermal fluid flow in a geothermal area. And then I just finished actually in the 2000 in the beginning of this year my PhD in a geothermal program called EasyGo, which was a joint program and dual PhD between RBTH Aachen and ETH Zurich, where one of the part of this thesis is like the one I mentioned today. I had also the opportunity to do many geothermal explorations, such as in Germany, also in Switzerland, Iceland, USA, like in Hawaii. Also, I've been working in Mexico and Colombia, my home country. I focus more like in the exploration, conceptual modeling, and numerical modeling. I really like to understand how all the geothermal system works, how make all the puzzles different, geochemistry, geophysics, so surface studies, everything is really funny for me. I really like it. And right now, I working in Seequent, like customer solution specialist, like of course in geothermal specialist. And in my area is more about the software Boltzun and leapfrog energy. Maybe in the future I can share more with you in this software in another talk. But today we're gonna talk about him. But before of that, there is many ways to, and also depend of the people or where your target, how characterize the geothermal system. Some people prefer like talking about enthalpy, like high, low, middle enthalpy. Other people depend on the geological context, but other people talk about how it's regional or more local. So it could be confusing. One of my favorites is this one table from MOEC. What categorize the geothermal system depends on, of course, the geological settings, but very not so regional, so more like local context. And here, the thing that I want to refresh you, or at least to mention, is because we're gonna use in the end. We're gonna mention a little bit, but the thing here is like I want to understand how come work the geothermal system according to this, of course, to this graph. So the main things like we are talking about convection dominate, like magmatic, for example, or conduction dominant systems. How gonna be the heat transfer? How gonna be like, is my convection is gonna be control for fall, for magmatic? If like conduction gonna control for, again, for structure control or lithophases. Like this thing is gonna be so characteristic because when I write to Ahin, that was one of my main questions. Like, what is control the geothermal here? Why we have this water? There is a magmatic source here because actually the thermal water here is quite interesting. They are very rich in minerals, and the smell of sulfate is like very characteristic like in volcanic context. But we don't have any volcano here, at least, or at least just in Aachen. So all these questions start to appear on my mind, and that was the main challenge when I write here in Aachen, like where we're gonna start. So this tool or that I'm gonna mention today is like little steps, or they're gonna mention some methodologies what I did for this, how develop the conceptual model. Of course, it's still a conceptual model. In the future, I hope other future researchers gonna make improve of this conceptual model. Conceptual model always gonna be evolved, but this is the question. I just have you one and keep in mind this, like, what is the main control of the system? So I mentioned early in the beginning, again, it's for 2000 years. We have a huge history about this thermal water, these springs. Even from the Roman times, they came here for a special place for relax or healing, or other activities. So we are like, Aachen is located in the triple border between Netherlands, Belgium, and Germany. Right now, this water still exists, of course. We have still water. There is even a spa here in the downtown Aachen. You can see this water. You can smell it. It's keep hot, warm. So it's really interesting. And again, like I mentioned in the beginning, you don't have any volcano here. And also the geological context here is quite special. Like gonna mention like further. But before that, again, like when I started exploring about geothermal in Aachen, the people in Germany mentioned about this map, for example. We can see the geothermal potential areas here. I hope you, oh, let me, there is a point here. So you can see like Aachen is this area, this geothermal spin. The people prefer talking about geothermal potential in Germany in the south, in Bavaria area, in München. Also in the upper Graben, where is right now a lot of exploration there, and the north, where it's like more legacy from the oil industry, but they have some, of course, some data from the underground, and they can see the thermal isotherms there. But in Aachen, you can see there is no, yeah, there is no temperature marks here. Like they put even like close to 40, 60, not too much interest. However, here, however, Netherlands, for example, Netherlands also have a thermal like potential area like map, and you can see actually in the graben rock graben here they put very high actually, and for Belgium side is something similar. This is the potential and the possible here. Like when it's cross the countries, for Belgium, Ireland, there is potential, but for the Germans, before was like not really. So it's like we're talking about political boundaries. Of course, not. This is geology. So one of the things that start to call my attention. Of course, when I write here, everybody talk about carbonates because you know that carbonates have a huge legacy about water or oil storage. In geothermal, carbonate has one of the there is a lot of reservoirs around the world. Actually, in the München area, there is like sandstone carbonate mixing reservoir. So also in the Belgian side. So yeah, the question was like, we have this thermal if there is a reservoir in a hypothetical reservoir, is in the carbonates, and could be. I mean, this is the question we're gonna see today. But yeah, the point here is like you can see like both countries see potential in this area in Germany, according to the past data, is not too much. However, like we like mentioned, like the chemistry, the water is warm here. We have like it's not just rich in carbonates, and we're gonna see also that the water here have another minerals not really according to just full carbonate rocks. Of course, in the fluid, the activity of the water moving on the ground, the subsurface could be like some interaction with other minerals, but we're gonna see that how it works. Um, Oh yes, something we're gonna talk. Also, a little volcano, was a volcano not active, but nowadays is like it's kind of a sleeping volcano. We also again mention that later, but just keep in mind there is a volcano, the Eiffel volcano here in this area, where it's around I don't know around 30, no more like 17 kilometers around. I don't remember exactly, but kind of close, and you can see we still have the graben, the lower graben. So again, keep more questions. So the carbon is the real reservoir here. How is the fault here? Because we are in a graben, almost in a transfer area, transfer zone. So how we can, what I can see with the water in the geochemistry in the faults. Now finally, the geological setting. How is happening? What is happening here in the geological context? Actually, we have a well, was exploration well made in 2005, and actually in this well we there is no any carbonate, so Aachen is in this area. The thermal water is the blue point. So the point here, like Aachen is like in the area here we have two main fault systems. We have a northwest southeast faults. You can see like normally the normal faults, and we have another trough faults, the opposite, cut in the, I mean, the normal fault actually is cut in the trough faults. We have the intersection of two major geological features like the upper reef graben and the upper Rhenish massif, I mean, sorry, the Rhenish massif and the graben. And again here, like they make the well here, we didn't find any carbonate rocks. The carbonate rocks in this map is the blue here and the purple pink. So yeah, actually, that the target was there. They don't find anything. Almost in 2 kilometers, they don't find any fluid flow there, like any feed zone. For geological history, was this well is quite interesting, but for geothermal was null, was very successful. Also, before to go to this research, I did a previous research about the fracture system here, how the fracture distribution in all the area. Really interesting. If the how can be the permeability in the where, for example, the raining when it's raining, how can travel the falls. This is another project, but I'm gonna mention just so quickly. The point is like I make a fracture analysis outside of these falls, this area of the falls here, and in the center you can see the different settings like how the fractures tendency, the directions. Just example, the one to mention here, I'm interested in is this area in the center. We present more corridors. Corridors like we have a very consecutive section of many fractures together, basically. So this here in this center we have more corridors outside. So we have in this between these faults, the Felbis and Lauresberg. And not just that, we also have more permeability in these corridors, where is also potential fluid flow. Again, this is not for exactly for this project, but just to keep also in mind the fractures in these areas more, the intensity is higher than the around areas. So okay, so for this conceptual model, what I did, of course, starting for the legacy data, what we have, what is all the information, bibliography, etc. Uh, of course, with all the bibliography information, I define my area. Then I took the information about the thermal water because like 20 years, 30 years ago was exploration about the thermal water here, the mega geochemistry analysis, but there is new methodologies, new ways to research that. What I did is like took this data and I also did a little deeper study of the data, deeper analysis. In human context, the thermal waters in 20, 30 years don't change too much. I mean, at least you have a huge activity, human activity, anthropology can affect that, but not in this context. So the ratio of the chemistry water like today or 30 years ago going to be almost the same. So I did like this geochemistry analysis, geothermometry. I estimate also some capacities. You can play with that, for example, with isotopes and estimate like the volume. This is a very interesting study. I'm gonna mention very brief about that. The stress analysis, I do. We have because the wall that I mentioned before, there is like stress data, so that's great because I could know how the stress in this area and do like evaluation how the fall is active or not. We can mention like that, or at least like if there is a high sleep. A sleep basically is like the probability that the fall is moving or dilation is open, or basically we do like both dilation and sleep dilation tendency. That could be good because that's not just for exploration, that's also for actually management, because when you do injection, you want to avoid some faults it's active. For exploration, this kind of faults can be also kind of flow path. Depends, they have both dilation and as good as sleep tendency. But I did the point here is like I did in this area for the main faults here, this control agent. And in the end, also we did also like magnetotelluric study, but this was like more like no a deep study, no a full study of magnetotelluric. We hear like more like forward modeling and some pre-campaign exploration. This is the purple points here. For MT campaign require time and budget. The only thing we can visualize here is like it's possible to do it because one of the challenge with the MT is like the noising. You can have a lot of noise coming from many things, railways, oil pipelines, the city, yeah, many artifacts can ruin your MT. And actually Aachen or all this area is very urbanized area. So that we want to see this challenge. It's possible to do it because of course we want to pavement a perfect road for the future researchers. Yeah, good news. I guess in a spoiler, yes, it's possible to do it according to our results. Of course, this is not gonna be appropriate for the conceptual model. It's just more like help, but we have the chance to do it, and we did it. So finally, like again, like with the results, what I want to check in the chemistry. Yeah, the water have many chemistry, many rich mineral, but what is the main important for us, or at least for this kind of studies? Of course, we want to see the first, the typical observation, like our temperature in the surface. We can see like actually LB is the hotter one. Is this one actually it's like it's like basically very close to this northwest fall, and basically is rising this trust fall. So you can see all the thermal water is like rising in the trust fall. But if you see it, when it's closer to this fall, the temperature actually is hotter, and also when it's more richer in minerals. So this is the high, we have the major elements like sodium, chloride, bicarbonate. That's why this water is categorized like sodium chloride waters. We also there is some information about the isotopes. The isotope, this is not helium, this is tritium. This is very important, the isotope, because we can recognize its like origin from the rainwater. But the rainwater also has this element, the tritium, where it is useful for the estimation of the distance of the water. We're gonna see that. But the point here is like, yeah, apparently all the water is in this area. This area is very common actually. The sodium chloride water is very common for active geothermal system, and we're related with the high upflow. Actually, when it's like in the area that is the outflow, when the water is like travel a lot, it's part of the outflow, the water is more close in this area. It's like more rich in magnesium, but this water apparently is actually connecting with the reservoir. It's like flowing faster. Actually, we can see in other elements. For example, the lithium is it's very volatile, and also at can like be absorbed for the clays. This lithium here is actually no low, but neither so high. So actually, it's interesting because it's like keep like same, very similar between all the waters. Also, we have a lot of silica to be just assuming we are talking about carbonate rock like we mentioned before. Where this silica come? Where did this lithium come? Where did this sulfate come? Yeah, of course, this sulfate came different source, but start to call attention. These kind of elements in my carbonate, just that it's like yeah, of course in the flow path maybe because when they are traveling absorb, but the magnesium actually is kept low. You can see the magnesium here is actually low. Normally when this travel a lot, the magnesium is higher. There is like also some other elements to get reached, but we have a very high chloride. Yeah, actually, the thermal waters here have a really typical behave more like a volcanic context. Like again, what I also want to check is like separate. Like we all, even they look similar, they are really are the same. I lose is the endogram clustering, and I check, for example, this group is slightly different to that. That's weird because this one actually is like the same default to this. So it's like mentioning before, it's like this group of water is maybe more related with the outflow. Maybe there is another fault here we're not watching the map. So yeah, that's what really important to understand where this thermal water is coming. It's really the trust fault, the main conduct, or actually this fault. That's why we're gonna do the sleep tendency. And yeah, I'm gonna show you that. But yeah, just keep this in mind. We have the LB is the higher temperature, uh, and also the direction of the elements is in some ratios you can indicate like how can relate it with the outflow, and the ratio of the LB in some elements show it's like basically the faster water like compared with the others. Actually in the flow rate you can see also that is the highest. Sorry, the flow rate here, yeah, it's too much higher than the others. So yeah, just that. Keep in mind that we have a really rich waters, and, but not all are the same, and LSB is like quite different. Of course, there is the infamous and famous jet thermometer. Some people don't is not agree, others yes. There is show some good results in some cases, or not. Also depend of your geological context. I'm not gonna teach to you here what geological context we need to consider for apply different geothermometers, but just want to know in this case because we have talking about the potential carbonate rocks or in silice cluster rocks maybe, and with some high slate magnesium, this one actually is quite appropriate. It's like sodium, potassium, calcium geothermometers. If you're not familiar, geothermometers is like basically is estimate the when the water interacting with the rocks, there is some, of course, interaction with the minerals, some reactions. And the point of this geothermometer is like in the moment with this mineral arrive with equilibrium with the hot water and the minerals. And the moment this equilibrium is like is you are it's gonna be the temperature because in the equilibrium is the temperature equilibrium. So yeah, that's very resume. But the point here is like this geothermometer could be actually very appropriate. There is a earth like go so far, like for example the sodium potassium gigabyte, but you can see there is all different sodium potassium, like this one and this one is very different. That's why some people like it and others not. I prefer use this geothermometer just like a little base, a little guide, but not just keep this is the only way. Actually, one of my favorites, or that I recommend other people recommend the multi component geothermometry was this one. Basically, here is similar to this, also find an equilibrium, but with many different minerals, not just because the sodium potassium, for example, is just maybe just assuming it's equilibrium with the potassium, with minerals rich in potassium, what the like feldspar. But here in this case, you are apply many minerals. You are assuming, of course, these minerals is based on your what you're thinking is your reservoir potential. And what I show here is like the potential temperature equilibrium if we are like the reservoir is around it's very close to 130, where it's like here you can see also here the peak very close to actually the sodium calcium magnesium correction. So basically here is what I want to teach tell you is like in Aachen, according to the classic geothermometers and the modern ones like the multi-component, we are talking about estimation about 120, 135. Depend on what is the heat source. If we are assuming there is like maybe a heat source, we don't know, but we are assuming like normal geothermal gradient. We are talking about, of course, more like almost 4 kilometers, 3, 4 kilometers. But however, this is assuming there is no any really heat source, but we're gonna see that. But the point is like here we are talking about 130, was actually is a very really good potential. I mean, for actually for a binary plan, assuming a binary plan, it would be great. With 130, 120 can worse. But yeah, of course, you need more than that. Go more little in the yeah, just to finish the geochemistry part. There is another important data to mention, and the Eiffel plume we told before. This is what a volcano plume was assuming was inactive, not existing anymore. However, the last research they measure like in some spring like very a lot of CO2, and that was very interesting because also we are talking about the CO2, or what is also very rich in CO2. Actually, in Belgium, there is some studies like which one is like 60 kilometers from the plume. We are like around 70. They associate these thermal springs in this Belgian area with the plume, like, and we are just 10 kilometers of the distance, and actually we are also quite close, relatively close to this plume. I'm not assuming this our thermal waters is related with this area with all these geological anomaly. But it's interesting to think like, hey, if this guy do some isotopes studies because they do the isotope study we couldn't. Could related the thermal waters there to the Eiffel plume. Why no can be our case? Just to mention, of course, we need to explore this area and find the analysis, but it's quite interesting. Unfortunately, we, in that moment, didn't have the budget to do like deeper isotope studies. Also, I'm gonna recommend which one in the after finish this part, but it's a good note. So the sleep, sorry for the XRP, the sleep tendency. Like I mentioned before, like I want to see how this fault system here is like acting like they are first like active, which and for according to the stress, how is the movement is a high or no, and you can see actually for the northwest faults, we have a high sleep tendency compared with the trust fault, which actually is moderate. And it's quite interesting because in the beginning, these thermal waters, everybody was assuming, well, not everybody, but many researchers are assuming what the thermal waters come from the thrust fault. But like I mentioned before, remember this water was more close. The faster and the highest concentration mineral waters was close to actually the normal fault. Yeah, maybe in the cross section between this normal fault here and this and the normal fault in the thrust fault is where the water finally find a way to escape from the underground to go to the surface. Have a lot of sense. We have also here like again these very active faults here. This is very good indication, but and we're gonna see that you can all these black points actually is like earthquakes. I'm gonna show after this slides, but you're gonna see how really active is this area in seismic. It's not a strong earthquakes, but it's still little a lot of seismic events here, and all the seismic event you can see actually is over. The most of them is over this faults. So even you have the slip tendency where it shows high, you can compare, you can relate it with the earthquakes, and like yes, definitely this fault is quite active. So with all this, he's the part that I like it, the mix of everything. What I have, so I have the chemistry, I have the sleep tendency, of course, the geological information that I collect before. Of course, we have also the fracture data that I showed in the beginning. Everything is mixing, but the so for in this model, because it was not really appropriate conceptual model. Again, this is one of the first conceptual models here in this Aachen. I hope in a future, some future research can do another research and can we can improve this. But for now, with all the geological information we have, what I assuming is like over the thing with this paper, because that's on a paper, like we have like a reservoir rock below to this Cambrian rock, very old. We have a triangle zone here in the triangle area where it's like the old rocks. We have a mix between carbonate and silicas. That was according to the geochemistry of the waters. Because we know this water actually is flowing faster. It's like not really have too much time to get interacting with the classic rocks to absorb all the minerals and keep the equilibrium. These water are actually in equilibrium. That the chemistry shows this. So somehow all the reservoirs like in a moment with connecting the reservoir with the thrust fault and the normal fault is where it ascend this part you can see and ascend to Aachen. So actually it's not really the thrust fault rise this water. It's a complex system, hydraulic system between the normal and the thrust fault interaction. All right, reaching to this whole area where it's like actually some faults and complex. We have these seismic events. You can see here, we have the seismic here. We have a lateral recharge because we know this water actually are from a meteoric recharge. The heat source is still unknown. There is recommendation, of course, to really because I think when we localize, we really define well which one is the heat source, and we can do with the geochemistry actually. Uh, this model is basically just totally like improve a lot, definitely. That's super important. Maybe in the context of when you make a plan, geothermal, but you just want to, there is water there. You don't care where it's coming, the history. But actually, for our, of course, geological interest and compared with another places in the world is quite important. So yes, we have a fracture reservoir, very important, influence for the faults with a high permeability layers and the reservoir volume estimation uh, estimate this, but again, this was estimate based on there is with the tritium water. I calculate uh, high explain because it's a lot. But I gotta mention the paper because it's quite complicated. It's many information. I don't want to keep going on that. The point here is just I want to show like how like all the dynamic and how is the water here. You can see the fracture flow, keeping the reservoir, mixing reservoir, fracture, mixing reservoir, and rise up. So, what are the conclusions? In future research, more than the conclusion is basically the Aachen. definitely right now looks like totally fault control. Like the system is controlled for the faults, especially the normal faults. Like actually this one Laurisberg fault, apparently there is a lot of influence. We are talking about mixed fracture reservoir. Also, the looks because the thermal waters and everything, maybe for the history we don't know yet, but we are talking about convection system. We in the future the recommendations to go further with Aachen to understand more, is do like a discrete fracture network, go more characterize more the fracture in the area, like showing the beginning, but the next step of this study. Of course, the helium isotopes. The helium isotopes is very well used for the heat source because for example, if we are talking about mantle volcanic influence, the helium isotopes gonna give you that idea. So helium isotopes in this water actually is not so expensive research. So I give you the data for someone who want to do a master PhD thesis in this area. This is the next step, definitely. Alien isotopes can help a lot, and probably my first recommendation to do in Aachen. And of course, like I mentioned, the MT study in gravimetric campaigns in this area, especially in the south. MT, of course, is very useful. You're gonna know a very deep level the resistive of the rocks there, and we can help. There is something happening. Yeah, in 3 kilometers around. Gravimetry is a great complement. This area is full of nature. The only bad negative this area I'm gonna tell you now is like it's a natural reserve. So actually, it's gonna be impossible to do like a geothermal well there. But however, doesn't mean here or here. I mentioned here the potential area for the study, but when you do a well, that's not necessary to do in this area. So remember, it's very keep important that. So, but this area not really protects. Uh, so the other orange area is it's interesting. Didn't mention too much here, but to take note here, the fault control system or in the growing this because we are in a growing contest here. It's very important to look at the transfer area, the transfer zone. The transfer zone I really recommend the paper from Fall, a professor in USA, in Nevada. He mentioned he will do a lot of studies in these fault systems in the where different fault settings. And the here is when we have the transfer zone. Actually, this one doesn't look, but this is a huge transfer zone, but regional. But because the scale of the map, we can see that. But this one is more local. You can say it's more small. But the important here is like these areas could be also potential. And actually, we can see the earthquakes here. Actually, this area I also really recommend for future studies. Doesn't looks very active and everything, but it's a transfer zone where a transfer zone. No, this is like a jump. Yeah, like in the ground, we have the little jumps here, where it's also show potential, but who knows? This is for future study. Yeah, that's all. Sorry, there is a lot. I try to be the most brief. I know there is many information. There is also the bibliography here. This presentation was based on this paper. It's published in Geothermal Energy. If you want to go deeper, of course, you can check that and write me personally. I'm gonna be so happy to contest any questions, any doubts. And yeah, thank you so much. That's all.
Thank you very, very much, Esteban. So now we can open the floor for questions. You can also ask your question from in the chat.
Yeah. I don't know. I don't know if I have another chat because it's separate or or the people is shy today.
I don't know. We still have almost 40 people in the meeting, so
The flow rate with talking is like in surface. I think that that information that everything that I did with the geochemistry of the water and include the flow rate, it was like legacy data. So was a PhD thesis was made here, and I took this data and I made my own analysis. The flow rate is part of this data.
Okay, so you didn't do the calculation. It was already
No,
there.
yeah, exactly.
Okay. So you didn't do any resource calculation.
For the chemistry part, no, it was more a full analysis
Okay.
from that part of the results.
There is another question about salinity. What was the range of the salinity of the water?
Oof, oof. Oh, let me see if I have the salinity there because I think I'm not sure if I put it. Uh, but it's quite high. It's really high. Let me see how salinity. No, in the table I didn't put the salinity. But I can guarantee is really high. Actually, in the paper, I mentioned more like the genesis of the water, like where is coming the salinity, the sulfur people, because in the beginning the people related this sulfate uh, with organic matter, but apparently there is more than that because you were talking about organic matter, we're expecting other in some other things.
Another question from Alberto. So we have, which is the most relevant fault system for this geothermal system? Is the northwest east trending system most important, the one related to the tertiary graben?
Definitely, yeah. The Northwest so is the apparently the most important. In the beginning, when I arrived here, like mentioned, the people really focus in the trust fall. But after the sleep tendency and checking how the water, like again, like water is like apparently it's more like flowing from the normal yeah, the northwest so east. Definitely, in all the earthquakes activity, yeah, definitely is the northwest so east falls. And especially we are talking again, we have a lower ground here.
Another question is, did you run any THMC simulation of the geothermal system in Aachen?
No, I would love. There is many things we can do it definitely, but the time.
Another question, do you think new 3D seismic will help to improve the structural model?
Always is welcome any geophysical study, of course, but that 3D seismic is not something very easy to do, and especially here in this area. You're gonna have many challenge in the budget. I think it's not really necessary for this case. I mean, of course, gonna give you information. It's beautiful how more details, but for me, I will focus more empty and gravimetry.
You mentioned this volcano, potential volcano, and you also mentioned in your presentation that as of today, we still don't know where the heat come from. You have like a kind of guess?
Uh, my hypothesis, what I thinking, maybe it's related with mantle, not necessarily with this volcano, but for me it's like mantle coming. But again, that's why I really recommend and really strong recommend the helium isotopes. It's very hard to get. I mean, we can assume many things like I don't know, Pluton, mantle, or just coming from directly for this volcano like Belgium, because that's crazy. Like in Belgium, they made it and we haven't. But yeah, that's my guess.
Any other question in the chat? Or maybe someone wants to unmute and ask directly?
It's a pity. I mean, like, I really highlight again, like, isotope study is not something so complicated nowadays. So, if someone is interested, please write me, and I think we can evolve this project in a very, very good thing.
Another question. Let me see. How many wells are available in the area or nearby, and what are the depths?
Well, really exploration well is this one in Arbete that I show you, like almost 2 kilometers, 2 kilometers point five. There is another wells like for more like for water, shallow water exploration, like but they're not really deep. So for geothermal, there is just one, and there is another maybe close in the area like 500 meters, but does not really give too much information. About there is someone mentioned peers have passed me. They passed me what I did. The earthquake event that I showed was like during the last 10 years, from 2010 to 2020.
All right. I will give you a few minutes for maybe last questions. Okay, no. Ah, is there any studies related to Curie depths and the geothermal temperature gradient in the region which can ascertain mantle plume related significance?
No, not really.
So what is the
The- For the
depth?
for the
Yes.
current that we need like maybe some magnetic studies and also and also maybe not more about the heat source, what is complicated. You can assume in, but yeah, maybe we need the more data. That's why I really recommend the other that I mentioned before. What's the depth of geothermal reservoir in the study area? We're talking about around 3 kilometers. Let me yeah, 3.5 kilometers around, between 3 3.5. Again, we don't have any geophysical study to go depth, so this is like assuming the geothermometers and the temperature of the water, and of course according to geology.
Okay, so do you know if in this area there is sufficiently dense gravity data that are available?
There is a regional map. I check it. The person make a lot, and there is some gravity data, but it's very regional scale. This is the problem. And that area show very high goals, but yeah, again, because it's so regional study, it's hard to use it. Dense gravity data area available. No, that's the thing, exactly. That's why I also recommend to do it.
All right, so we are at the end of that hour. It was very, very interesting. And actually, as you said, I would love actually to know more. So feel free to contact Esteban Gómez-Diaz. And again, Esteban, thank you for taking the time to presenting that very interesting subject. Thank you everyone on the call for listening in. And we recorded the session so you can find us back and listen again in YouTube, if I'm not mistaken.
Thank you so much, everyone, for coming, for attending. I appreciate it. Have a good day.
Thank you. Bye
Thank you,
bye.
Eileen. Thank you, madam. Bye bye.